Welcome to our lectures on number conversion. So this time we basically will see, we are now to the last part. We will convert hexadecimal base 16 to binary of base 2. So it's again a very easy process. Let us take any number, let's say 1, A, B and 2, right? This is the hexadecimal number and we require the binary equivalent of it. So what do? You just spread this hexadecimal number a bit wide, right? And since hexa is 16, 2 raised to 4, right? So now write 4-bit binary equivalent, right? As a result, basically having this chart in your mind actually helps. So now let us just change the pen color. So the 4-bit equivalent for 2 is 0010. So this is 0010. 4-bit equivalent. So let me change the pen color. 4-bit equivalent of B is, so this is B here, and for B the binary is 1011. 1011. Now let me change again the pen color. For A it is, so if I go to A, so let me just cross this. So for A the equivalent is 1010. And then finally we have 1. For 1 of hexadecimal, the equivalent 4-bit, right? Remember, you have to always write the 4-bit equivalent, right? So what do I mean by that? So for example, when I had 2 in the end, so even though 2 has preceding zeros, so you have to always write the 4-bit equivalent, right? So finally our answer is 1AB2 of base 16 is equal to 001 1010 1011 0010 of base 2. Finally, when you write this answer, only then you can ignore the preceding zeros. 11010 10110 010. This is of base 2, right? So another example, let us take. So let us take a simpler number. So let us take 2F and 8. This is of base 16. So just write in a spreaded form. And now just start writing the 4-bit equivalent. So for F, we have binary as 1111, 1111. For 2, we have 0010. And for 8, the equivalent is 1000. So 8 to F of base 16 is equal to 1000 0010 1111 of base 2, right? So that's it for this lecture class. Have a good